Okay, good morning, everyone. I've just started this session. We're going to give everybody about 1 minute to join. I know sometimes it can take a little while for everyone to come through, but I can already see we've got a decent set of people attending. Just want to quickly say thank you for everybody who is here. I had a quick look through the attendee list, and there's a wide range of people, from some people I know are very experienced, and definitely some new faces, and some people I know who are new to the industry. This event, I'm going to try to make it lean more towards being accessible and open to everyone. So the examples will be, let's say, more approachable and simple. But for my friends who are joining who are more experienced, this is a great opportunity for you to also throw some really hard questions at me later, sort of challenge some things. There's not just one way of doing it, and we can have some really interesting discussions throughout. Okay, we're about 1 minute in, so I think that's good enough for us actually to start. I'm sure more people will come along as we go. Okay, let me just move ahead. Okay, a little bit of housekeeping. The first question that everybody asks is if this session will be recorded, and yes, it is being recorded right now, and it will be available after this session. Actually, if you go to this link, you'll be able to access it immediately. And we will also post a copy on our YouTube channel, so you'll be able to get there. We want this to be a sort of interactive session in that people can chat either with us or with each other, and then be able to also answer questions. So you'll see on the screen on your right-hand side, you'll see a chat logo. This is where you can talk, say hi to everybody. You can also go to the Q&A section where you can ask questions directly about the things we're doing, or anything that appears. And it's really helpful if you put in that Q&A section, because if you put it there, other attendees can actually vote up questions that they think are interesting, and then we can get to those ones first. And it also makes it much easier for me to walk through those questions at the end. Finally, I know that we want this to be sort of an interactive workshop, and the actual model build that we'll be going through will actually provide the files, so you'll be able to do this afterwards, right? So because I know everybody learns at different rates, I think the best thing for everybody to do is just to watch this session, follow along, ask those questions, and then we will provide the files for you so that you can repeat these same exercises in epanet-js or any modeling tool that you want, right? So also, if you're watching this after the fact, we'll have it either on the link at the bottom or within the text itself to those files, so you can do this yourself. Okay, with that, yeah, feel free to start chatting, saying hi, and asking some questions. A little bit of an agenda today. I'm going to give you a brief intro into epanet-js, what the project is, what we're doing. You can think of this as a little bit of our, if you go to a timeshare, we're going to do a little sales pitch. I'm going to keep this very short, like less than a couple of minutes, right? Just give you that background. Then we're going to go into a bit of a little bit of discussion on what entails in a model build, give you the process. But then the fun really starts. We're actually going to build the model. We're going to look at some GIS. We're going to build that model. We're going to clean it up. We're going to get it running. And finally, we'll close up with some Q&A. This will be hopefully the exciting bit where we can either clarify things that we did. You can ask questions on the process, anything that you like. Okay, so let's get into it. A little bit of a brief intro to epanet-js. Some people may know epanet-js, some may be totally new to them, but epanet-js is a modern web-based hydraulic modeling platform that's built on top of the epanet engine, right? It allows you to build, simulate, and analyze water networks directly in your browser. So you can imagine it more like a modern version of those traditional planning tools that you've got, so like InfoWorks WS. We're trying to reinvent that in a way that is accessible and open to everybody, right? Just get to the browser, put in the address, and you can start doing hydraulic modeling straight away. The other really big thing about epanet-js is we want to support that epanet project. Epanet is that open source engine that is used throughout the entire industry. And we want to support it by also contributing back and being another open source alternative for it. So epanet-js has public source code from day one. You can actually go to GitHub and see all the source code for the application, and it transitions to a fully open source version after 2 years. I'm also personally a contributor to the epanet open source project. There's fixes. I was involved in epanet 2.3, and we want to make improvements to the engine. We'll do it directly. So not only just benefits epanet-js, but it benefits everybody in the hydraulic modeling community that does any type of modeling, if it's in our platform, another platform, or data science. I will say, if you really want to know more about what we're doing, we did a previous session. This is the best place to go. I won't hold you up too much on it here, but you can go back and watch that session. We talk about our motivations for why we built epanet-js and why we want to make it open source, and this idea of trying to create a sustainable solution for everybody. So that link is there. We can you'll be able to share that afterwards as well. Finally, the last thing, we are moving very, very quickly. People who are following us on LinkedIn probably see that we're releasing new features almost every day. That may be too much for some people, but once a month, we also release a progress report on our website and on our blog. And then we detail all the new features that we bring out for that month. So definitely a good way if you just want to keep a view on the sidelines or understand what's going on. These progress reports are very handy. Also, if you sign up for a newsletter or you register for the app, we send one email a month, and that one email is always the progress report. We don't want to spam you with details. This is the best way to keep track of the project. Perfect. Sales pitch over. That's the timeshare bit done. Let's talk about model builds and how they work. And specifically in this session, we're going to be talking more about model builds from scratch, so from GIS data, from not an existing model. There is an alternative path where you have model maintenance, and that's a slightly different challenge where you want to maintain a model and keep it up to date. Here we're talking about going from a fresh model. I thought it'd be good to break it down to a couple of sections as you go through this model build, right? The first bit, it's all about understanding what you're building and why, right? So the first key thing you have to do is understand what's the purpose of this model build, right? Are you building a simple planning model, or are you building a digital twin, right? They're two different extremes of the spectrum, and they will contribute to the level of quality that you need, right? So I would say figure that out early, and then err on the more simpler side, because it is easier to bump up the quality of model than to sit there spinning your wheels when you don't have it. You have to go through that process of then collecting all that source data. I've got actually a list on the next couple of slides for things like GIS, asset information, elevations. Like you want to just collect as much data as you can. And then really, once you've got that data, do the QA/QC. Don't just run and jump straight into a model build. Check that GIS data. There's no attributes missing. Make sure you've got all that key information from SCADA and telemetry that you need to do, like a flow balance, or like enough information to understand how the network's working, and cross-check things as well. Like, have you got an asset registry says that the tank is X size, but you've got as-built that are different? Make sure any of those errors are known ahead, and especially maybe do a light flow balance to make sure that the water that you think is moving through your network, you can actually account for. From that point, you want to start building the network, getting that GIS data, getting it in. The most important step is to try to get a solid network in one go. And then I always advocate for trying to get that model running as quickly as you can, even from one steady state, and then moving into extended period simulation, even before calibration, if you can. And then finally, you get to the calibration bit. This could be a whole webinar or a series of webinars, so I won't go too much into it. Actually, in the next couple of slides, I have some details about it. And finally, using the model. When you close it down, make sure you document what you've done, and then start doing planning, operational analysis, digital twins. Okay, I've got a couple of slides. The next one, I'm just going to show them for reference, but I won't stop to go into detail. Potentially, if we have questions, we'll look at them afterwards, right? So here's a couple of slides with a lot of text. You've got 2 seconds to look at it. Got another 2 seconds, another 2 seconds. We'll publish these on the website with more details so you can see them, or we'll reference them in the Q&A. Okay, so that was all the talking done. Let's get to the fun bit of actually building a hydraulic model. I think that's the best way to see how it's done, and walk through the process and understand some of the issues or ways that you can do it. Like I said, there's many ways to do it. This is just going to be the way that we follow it in this more simple example. We're actually going to build a real water utility using real GIS data. This is open data that is being provided actually by TasWater in Tasmania, Australia. This is a small little sort of semi-rural water network. It's relatively simple. We have a single water treatment works with a pump station. That pump station then has a transfer main that goes up to a gravity tank. And then that tank, the transfer main goes into the tank, and then there's another one that comes down and feeds the remainder of the network by gravity. So no other booster stations or PRVs, because I wanted to keep this relatively simple. and really approachable for anyone to be able to build this type of network, right? So only 600 customers, about 20 kilometers of pipe. I'm also sorry, we're going to be doing this in metric for my US friends. We can maybe in the future do a US version on one for you too. So the task that we'll actually be doing this workshop, like I said, I will follow through first. And then later on, you can watch the recording and try to do these same steps yourself. So the first thing we're going to do is we're going to look at the GIS data that we've got, see what's missing, what's available, what's important, what's not, and then filter it down. We're then going to go through the steps of actually building that network, getting it into the GIS, getting it all connected, and then doing a validation of the model, making sure all those bits and pieces are connected and we can run it. And then we'll run the simulation to show that it can work. We'll set up the extended period simulation by, getting those customer points in and having a time series pattern to have varying demands, and also set up some controls. And then finally, we'll do a fire flow simulation. And if we get some time, we might be able to do some operational things. And actually, we've just got into scenario management as well. It's not released yet, but if it is something of interest, potentially we can also sneak that into if people are wanting to see how we're going to be doing scenario management. Finally, the last thing I want to say is this is just going to be the first of a series of videos on this. If people find this interesting, let us know. What we're thinking is that we'll take more of these open data sets and actually build the models and record the process and publish them on YouTube. So if you find this interesting, let us know. We'll start working from like smaller, medium, and large networks, and videos ranging anywhere from 10 minutes to an hour of actually walking through the process of building real models. So yes, if you find that interesting, let us know, because we think that's going to be a very useful exercise for people in this industry. With that, I think we can actually go ahead and start actually building this network. So first step, as I said, we're going to look at the GIS data. I'm going to pull this here. So we have, this is a little town here. This is actually in, make sure I don't lose it. This is Tasmania, Australia. We can zoom in. TasWater actually provide all this data as open data. We can see here, as we saw in the other diagram, we have our gravity network. We can see here is the treatment works. They just have a single point for it. We can see this transfer main that comes up, and then we can see tanks here as well that then come back down, a little bit of internal pipe work. Now, there's a lot of extra pipes in here that we don't actually need when we do a model build. So for example, if I look here, you can see there's this raw water main. So this whole system over here, you can see they're getting it from, I assume that's a lake or some other type of system, or maybe it's a well here. I'm not certain, but it then comes across to this actual treatment works here. We don't need this thing, so we'll actually be filtering those out and removing them. In addition, there are some additional type of things like overflow pipes and channels, scour pipes. We don't need those. So those are the things that you would typically want to like filter out when you're actually building them as well. Otherwise, they'll just get in the way. They're not going to be included in the network. Additionally, sometimes you'll have things like abandoned pipes or private pipes that maybe you don't want to model. Luckily for us, they are set as separate features, so we can just avoid bringing those in. But definitely when you're looking at the attributes for the water mains, you want to check to see, do we have any of these extra pipes that aren't necessary for the model build or would be inaccurate, say abandoned pipes. Luckily for us, we just don't have to include them. Finally, you want to look for key assets. So for us, we have the network structures. We know that we have a water treatment works. In this case, we know there's a booster pump here, and then the tanks here. They also have, control valves, but we have no control valves in here, so we don't have to worry about that in this version. There are isolation valves and some others. Once again, we don't need that level of detail in this model, so we won't be bringing anything in. And finally, there are fire hydrants. In this model, it's not necessary. In Australia, they put fire hydrants everywhere, so you'll end up with lots and lots of junctions, and we won't include them, but if you wanted to bring them in the model, you could too. Finally, the customer points. So we can see here, this last one, all the actual customer points that connect to the network. You can see, maybe it's a little hard with this map. You can see where they are all connected in. We will bring those customer points and allocate them directly. That will be our source of demand in the network, right? The way our model works is from your custom points are actually pulling that water from the tank. So it's important, it's a demand-driven model to get accurate representation of that demand. And so if we know the location of each of those customers, we can bring them in. Through the magic of doing things beforehand, have already gone and filtered all these assets for us to make it a little bit easier. What I've done is I have removed all those unwanted raw water assets. I've deleted them to clear it up. I have not taken in any of the other things like the abandoned and private assets. I've brought across all the customer points, and I've separated the tanks and the waterworks as separate elements so we can import those in ourselves. I also did a little check, sense check on things like diameters and confirmed that we had all the attributes that we needed, things like asset IDs and diameters. Lucky for us, this data was in good shape and there wasn't, or maybe these are the raw waters. Oops, that just break. Oh, no, it's come through. There were a few sections where it has, oh, here we go. Sorry, my mistake. Yeah, some unknowns. But for the assets that we're actually bringing in, they were all available, so there was no problem. There was actually one main where it was unknown, but it was a little small little service main that we could, I think it was here, we should estimate being 40 millimeters or like 2 inches. So with that, and the last thing that we did, we also added in some average demands. This is liters per property per day. This is just synthetic data because we don't have access to people's private actual water usage. So we just dropped some data in here. Okay, so I feel confident that we've got enough data now to actually be able to build this model. So now let's get to the fun of actually putting this in epanet-js and actually building that network itself. So yes, always important to just check you've got all those figures and everything that you need to start with. I'm going to bring across epanet-js. I've also got here all my files. I've already prepared them. So if you want to get to epanet.js, you can go directly from the home page and click this launch button, and this will bring you into the app. And then you can see from this welcome screen, what we want to click on is the import from GIS button. This is going to help us actually bring in that data, do the connections, get it all up and running to start with. First thing we're going to choose is our unit system. We're going to pick metric for this, and we're going to do liters per second. Now we're going to drop in our GIS data. So I'm just off the screen, I'm just selecting everything and dragging it in. Okay, and now we're just going to allocate things to the right set of elements. So if we have the tank, we'll assign it to the tank. The water mains we'll put to the pipes, and the waterworks we'll do it as a reservoir. And you can see that that's come up here. Okay, we're happy with that. Next step is attribute mapping. So we have the pipes, the tanks, and the reservoirs. For this, we're keeping things simple. We're just going to do the asset ID, which is this MX asset number. You can see that's popped up and previewed on the bottom here. And for the diameter, we'll pick diameter. You can see that's filled in. For roughness, we're just going to leave the default. 100 is actually extremely rough as a default, but it's fine for this purpose. We're just going to leave that as it is. You could pre-calculate the roughness either by using default value or more appropriately looking at the material and the age to pick a roughness that matches. For the tank, for us, the only thing that really matters is the ID. We'll leave those other default informations and we can update them later. And the same with the reservoir as well. Let's pick the ID as well. With that, we can build the model. This is going to happen very, very fast, but what's going to happen is epanet.js in a couple of seconds. It's actually bringing that data, connecting all those intersections, right? So if there's like three-way intersections, it's like snapping it all together. If there's overlapping things, it merges them together and makes this interconnected network. And we can see we have all those bits and pieces. So this is a tank. We look at the satellite image there, and then this is our where our supply source comes from, right? And the problem is, and I'm sure most of you know, if you tried to run this right now, it would fail, right? And if you've ever done anything with epanet, you would see it would just give you this very vague warnings that your system is ill-conditioned at this node and these are closed. But that doesn't really tell you what's happening. And to help us solve that, we have added in the network review panel into epanet.js. So up here on the right-hand side, we have the network review. And if you click this, we get a series of tools to help us clean up this model and get it to a stage where we can run it. We have a series of options, so orphan assets, proximity checks, crossing pipes, and the connectivity trace. I'll start with the connectivity trace. The connectivity trace, you want to end up with one interconnected network. All the pipes and assets are all connected together. And we can already see there is a range of separated networks, right? So we can see this first one, it's the majority of the network. Here we can see that there's a separate network. It looks like it's connected, but it's not. And if you zoom in, you'll see straight away, hey, there's actually a problem. There is a disconnection here, even though it looks like it was there. So these can cause all types of havoc on your network if you don't have these connections. In here, it's more obvious because it's totally disconnected, but in other places, it can lead to gaps in your network that you don't expect. Here, actually, I didn't totally delete everything. These are some internal pipeworks that aren't important, that cross-connect the tanks, and also have some drainage. We can just press delete, and those will be gone. Same with this. This is just some weird pipe that shouldn't be there. I don't know why it's in the asset registry, but we can get rid of that too. And this one is these two are overflow pipes for the tanks, so we can also get rid of those. With that, and then finally, the sixth one is the transfer main that's separate. We will connect that in too. Okay, so maybe the first thing we can do is connect this transfer main. There's two ways that you can do this. One is that you could go up here and get a pipe, choose the diameter that we want, let's say 225, and then click on this junction and click on the tank. Okay, that's one way. The other is you can just grab this junction here, drag it in, and drop it on the pipe, and then connect it in. And that also works as well. Whatever you need or want to do, both options are available. Let's go down and also connect the reservoir here. We can click this and drag it in, and we have it connected. Though we said we had a pump station and we needed to connect it in. So you don't have to go and delete or split. Actually, you can just add that directly in. So if we go to our pump, and if you draw a straight line across a pipe, epanet-js will actually split that in place for you. So we have our pump. I'm going to click here and here, and we can see we've now split in a pump at that location. I'm just going to go to the asset panel and disable this pump, or just turn it off for now, and allow the system to run under gravity at this stage. We still have this one disconnected network. So we can connect this, but before I connect it, I want to show you one other feature that is important, which is the proximity check. So the proximity check allows you to find locations where there may be assets that are close to each other, right? So in here, we're checking a distance, a proximity of 0.5 meter around. So we'll look at the end junctions and then look around and say, hey, is there anywhere potentially this could snap? And we can see this has been identified as a potential source where you might want to connect it. So we can zoom in, click this, and then drag it across and snap it in, and then that is connected. We can look at a few other places. This is also, looks like it should be connected. So let's see what's going on. Actually, this is disconnected and incorrect as well. And once again, yeah, we feel that this should be here. If we were missing this, we would lose a way for water to be routed through the network, right? So this is also important. So we come here, we drag these two together, and then we have it properly connected. You can work through the list. Actually, I've done this before, and these other ones are just coincidences and nothing of note. But this is a quick way you should definitely go through and just confirm all those connections are correct. This looks like it's fine, right? So we have done a proximity check. Now, if we look at connectivity trace, we have one interconnected network that is all there. There's a couple other tools like crossing pipes. So if you're working on a North American network that has four-way connections, this is also super helpful to be able to find those and to confirm if they should be connected. In this network, they don't do four-way connections, so it won't be an issue. But you can press up and down on the list, press the plus and minus button to zoom in, and quickly confirm if there's any actions here. Finally, we also have orphan assets. I've actually fixed everything before we get those, but they would tell you, do you have tanks, reservoirs, pumps, that type of assets separated in the network, right? And they would, if you did the import, so also helpful for things that would fail. We don't need those, so I'm just going to do undo and remove those assets. Okay, so actually, one other thing I want to mention, epanet-js, when we've done the import, has actually calculated all the elevations for us automatically. So we didn't have any elevation data. We have a global elevation data source, and these get filled in automatically as we fill in, as we import the data. So, or if we draw new assets as well. So that also makes it much faster. So at this stage, I think we're good enough to run the asset. We have a full interconnected network. Let's run the simulation. And it was successful, no problems. It came to a solution. And we can just check now to make sure everything is reasonable. So we'll go across the map, we'll look at pressures, and we can see, okay, this looks good, right? There's some higher pressures up here, but this looks, reasonable, right? So higher up in these elevations, it comes down, it sort of works, no problems. yeah, this is a good sanity check. You might want to look for other issues here, but like if everything's looking good, we can tick this box to say, okay, we've got that model running under steady state. The next thing we should do is actually get some demand, some flow moving in there. So we're going to import these customer points. But before I do that, I'm just going to create a demand pattern for our customers. So this actually is a new feature. It's not available yet, but hopefully next week it will come out that allows you to define demand patterns. So in here, we have the operational data, demand patterns. We can add a demand pattern. I'm just going to call it domestic. And at this stage, I'm just going to keep it as a 1 times multiplier. Later, we'll expand this into extended period simulation. And now let's import those customer points that we saw before. Oops. Sorry, keep editing. Press the save button. That's important. We have an item here for importing customer points. We can click this. This will import those points that we said and work us through the process of actually importing those customers. So we click in. We get that customer point file that we had before, and we can just drag this in. And now we have a couple of fields to put in. So first one, what is the demand? And this will either be in liters per day for metric networks or gallons per day. And then this will average down to whatever time frame that you're working on. Secondly, you can put in a label, right? So you can label the customer points, and then we can put in a time pattern, either constant or in this case we'll do domestic. Once again, it was constant, but we'll bring that in. Next, because we don't have any demand, we don't have to worry about this. We'll replace it, but we're not replacing anything. We're just basically adding into the network. And now we go through our allocation rules. So from here, we can choose what is the maximum size pipe that we want to connect to. This is 300 mil or 12 inches. What's the maximum distance that we want to go? 100 meters. And we can see how many of those customers are allocated. So in this case, 663, which is all but 2 of them. So what we could do is we can click edit. Now we have 2 options. Either we could just extend this out and make it further, or we could do some interesting things like, not that I would advocate connecting to a 600 mil, but we could, like, if you're in a rural connection and you could maybe do something like this and then finally go and then go to 1,000. Let's see what happens if I do this. Okay, yes, you can see now it will work through those rules, connecting those customers. And we can see those other 2 customers we're able to connect if we extended that distance a little further away. We'll click OK. And yeah, it's actually imported the customer points. So if we zoom in now, we can see each of those customer points have been imported and allocated to the pipes directly. These are virtual elements, so they don't actually split into the network. And the way it works is it connects to the closest pipe, and then it gets allocated to a junction nearby. So if we select this, if we select the pipe, we can see here the list of the connected customers. You can see those are highlighted, and we highlight over them. But if we go to the junctions itself, we can then see the customer points and then see which ones are connected. Actually, let's find one where it's on either side. Maybe this one here. You can see, okay, it comes on both sides of the point. So it's always being moved into that location. The nice thing about having the customer points is if there is a mistake in the allocation, it's really easy to fix it up and put them in a new place. For example, these customers have been allocated onto the transfer main, which we definitely don't want. They should have been on this one over here. Eventually, we're going to add support so that you can allocate per selection list and things like that to avoid this issue. But for now, I'm just going to quickly show you, we can move this customer onto the pipe across the street, right? So we could follow through and go, oh, actually, there's quite a few of these. Let's just reconnect. But for now, I'm not going to worry too much about it, but we can always adjust later. And you can see now that those have been placed in the right location. It's also always going to snap onto the closest part of the pipe unless you hold shift, and then you can pick anywhere. Okay, we have customer points in. We have a working network. If we run this, we should be able to see that flow happening in the network. Let's press simulate. It was successful. And now if we go to the map, we'll put on both the pressures, but we'll put on the flow. And okay, now nice, we can see that water flowing through the network. We can come here, we can see a flow rate about 7 liters a second. And then, yeah, we can follow that water as it moves throughout the network, right, using the flow arrows, right? Obviously, it's going to come down from the tank and come this way, right? You can obviously see where it's darker, more flow is coming through. So very quickly, we've created a steady state simulation of this network. Steady state's nice, but let's actually maybe make this a extended period simulation. So the only thing we have to do here is update the model settings, and then also update the pattern, and that should be good enough to get us into a steady state simulation. So the first thing we'll do, we can go into demand patterns, And like, let's add into here. So what I'm actually going to do is I'm going to grab a pattern domain me. I'm just going to get it from the side. Normally you would do a flow balance or some type of other way to calculate this. I'm just going to use an existing pattern. So I've just copied it from Excel and pasted it in, and you can see that pattern's come in. And actually, because we have steady state, it's highlighting. It's actually only using a single point at the moment. These are all grayed out. Let's go back and then change this from steady state. So sorry, I went into the settings up here. I'm going to change the time analysis mode to extended period simulation, 24-hour simulation with 1 hour time steps. If we go into patterns now, you can see that it is now running that full period. And for example, if we went to a 48-hour period and it went to the patterns, you'd see that it would repeat, and it'll be in a lighter color to show where that pattern is actually ending up and repeating itself. Let's go. Oops, well, I pressed simulate. Let's do a 48-hour simulation. It's not going to hurt it. We can see we've now run a 48-hour simulation. And if we go and look at this pipe, actually it's a bit negative. I don't love it being negative. We can click up here to reverse the pipe. I'm just going to rerun the simulation, and now it's facing the right way. You can see here we go over a 2-day period, this simulation. You can see the diurnal pattern of the demand. And we can also visualize that here if there's any changes in the network, right? So we can click on the time browser, pick different time periods. We can obviously see the network, the flow is increasing or changing throughout the day. The pressures are remaining relatively stable, but if there were any changes, we would see those colors changing. We can also potentially change the way that this is done, and maybe we'll see some more interesting results using this. Let's see. Yeah, we can see them moving a little bit more, right, and changing as they go. So yeah, really good. We've got an EPS. However, this is all working without that pump, right? So if we go down and look at the tank, fortunately that tank is draining away. So now is the time to start adding some controls and getting that pump running. So we have that transfer main. So let's go back down to our pump here. I'm going to just turn off some of these visualizations, make it a bit easier. Now, this pump, actually, hopefully in the next few weeks, we'll have it so you can design full pump curves. But for now, we're just going to do a simple 1-point pump curve. So all we have to do is say, what is the design flow that we want, and what is the design head that we want to apply to the system? And it's, actually, in this case, it's relatively easy to figure out what we want because and especially because we're in the metric system, we can look at, oops, apologies, this head is incorrect. Let me update the head at this location. At the moment, it's just at 100, but instead I want it to be, let's just imagine that it's at the surface, right? So 162 meters. So that means at the suction of the pump is technically 0, probably not more realistic, it would be much higher. But we can go, okay, so we figure out it's 162 at this location. This is the head. And we want to get to the tank. We look at the head here. We can see we want to get that to 240. So we need to go 240 to get 162. We need to lift the head at the base of the water treatment works about 80 meters. And so we'll say, okay, we want a pump that can lift the head about 80 meters to get from the treatment works. And we want to have a flow rate of about 20 liters a second, which is about 3 times the daily flow. So we'll definitely get it filled pretty quickly. We can then switch this initial status from off to on and run the simulation. And we can see, okay, it's run. Because the curve wasn't perfect, it's actually running slightly below the optimal point at 18 liters a second. You can see it's running all day long, and as that tank is filling, it's decreasing the flow rate. And if we go up to our little tank here, we can see now that tank is filling. It's going the opposite problem where it's getting high. So at this point, we want to add some controls and logic to make it turn on and off depending on the level of the tank. We can do that in the operational data here. We can pick controls. And once again, I'm going to just cheat a little bit and copy some controls in. These are very simple controls for epanet. I don't love having to write them out. Eventually in epanet-js, we're going to make it so it's configurable in the asset panel. But for now, you have to write these simple control rules. So basically read it as link pump 1, the speed of 1, so it's turned on. If the node, which is the, let's call it RSBWS 02-004, which matches the ID here, is below 4.5 meters. And then if the pump is off, if the tank is above 5.2, right? So these are the controls. We can save them and run the simulation. And then we should see, okay, it's done that exactly right. So as the pump is, the pump starts on, it rises to 5.2, and then it drains down. Let's make it a little bit more exciting, and let's just do 4.9. We can edit this. We can edit the rules. It's 4.9 that it switches. You can see, okay, the tank is doing a fill and drain cycle over 2 days. If we look at the actual transfer pipe, we'll see it has that sawtooth figure. We can obviously run it for a longer period of time. Let's do 120 hours. And then you can see, okay, it's extended and the tank will be nicely cycling here, right? And if we look at any of the points of pressure here, we can see, okay, we get this little pattern of the change in pressure throughout the system. Okay, that's pretty nice. I think we have a running extended period simulation in under about 20 or so minutes of a real water network using real GIS data and real demands. What we're going to do is we're going to save this. I'm going to click the save button, and I'm going to call this Roseberry. The thing with epanet-js is actually, even though this is in the browser, this is all done on your local computer. So when I save this file, it's actually saved on your local computer, and nothing goes on the cloud, nothing goes anywhere else. Even the simulations are done locally and kept private. At this stage, I think we are probably ready to do a Fireflow simulation. I'm just going to change this back to 24 hours on the simulation. At this stage, we don't have Fireflow simulations directly in the app, but we do have a side app that can help us. So up here in the help, we have our utility apps. If you select this, we get to go to our utilities website. We got a couple of interesting tools like data extractors, projection conversions, but the one that we're going to use is the Fireflow analysis. We go in here and we can get that file we had just built in here, this IMP, and we're going to drag it in. And we can see the network is here, and we can define some attributes. And what this is Fireflow analysis is going to do is it's going to test the capacity at each of the junctions to extract a certain amount of water that can simulate Fireflow, right? So you might have a requirement of 10, 20 liters a second at each junction. You want to see, okay, where in my network am I deficient in this? Maybe like 200, 2,000 gallons per minute, that type of thing. So what you can do is we can pick our simulation time. 7 a.m. is our peak hour. This is an Australian network, so the requirements for flow at hydrants is quite low. We'll do 15 liters a second, and we'll just do a very low minimum pressure of 5 meters. So what this will do is it will test each junction's ability to extract this flow rate at this time and make sure the pressure doesn't get below this. We can just calculate, and it's done. I don't know how many junctions we've got, 100 or so simulations all in a second, and we can see quite quickly where simulations are passing and where they're failing. If we go down to, say, this junction here and we select it, we can look at the row. We can say, okay, here's this junction. Here's the initial pressure, 72 meters. We also calculate what the maximum flow rate is. We basically say, okay, how much water could we take out of this pipe and before it gets to 5 meters? And in this case, it's 100 liters a second. So we know we need 15, so it's definitely going to pass. So then we do the calculation at 15 liters and it says, okay, if you take 15 liters a second, the residual is 70. This then does a couple other cases. We can see it highlights where it's failed. So if we click here, we can see the Fireflow available at this location is only 6.57. So at 6.57 liters a second, we get down to 5 meters. It's not possible to get 15 meters, obviously, because 6 is less than 15. So the availability is low. Or there is also, it can fail if the initial pressure is lower. If the initial pressure is lower than the minimum pressure, it just won't run the simulation. And with that, we have a Fireflow simulation as well. So we have built the network, we've got the demand in, we've done some patterns. Obviously, you probably want to do some calibration and confirm some things in this point, but you can show how very quickly we've gone from just GIS data to a running model, getting an extended period simulation, and doing a Fireflow simulation, all like within like one little session. At this point, you can do master planning. Like you could look at options to like make this more like maybe you want to look at options to extend the water main to give more supply. Maybe you want to do some operational things like, oh, maybe we have an opportunity to make these like DMAs and separate them. Or maybe like we saw there was actually quite high pressure at this location. So maybe we could look at some options of like, let's get a valve, place it in here and make it a PRV. And that's 20 meters and run. And you could do, well, that's obviously not going to work. You can see straight away it said, hey, if you do 20 meters, the pressure is too low. Let's do 30. Probably it's better to actually do some calculation to figure out what the minimum pressure should be, not just slam values in until it works. But you can see that obviously is there. You can do that type of work. Okay, with that, I think we've covered the model build. Hopefully, we've got a few questions coming in. We've got ourselves about 20 minutes now for Q&A, and I've got a second to do some drink some water. Just give me a second. Let me just load up. Where did I put it? Maybe I deleted the slide with my slideshow. 2 seconds. Yeah, so we have on the right-hand side the Q&A, the questions. I'm just going to load up a pretty slide here. Okay, here it is. Okay, and then the slideshow. Let's get down to, yeah. Perfect. Okay, my screen is on the left, so I'm looking away at everyone, but I'm going to quickly look at the questions. Oh boy, we have so many questions. Well, a lot, at least the comments. We got a lot of questions here as well. Let's okay, so boy, yes, lots of comments. Hopefully we can get through them. Let me just pick the first one. Okay, so if you go to the questions panel, so that's the little box with the question, you can also upvote anything that you think is interesting. Okay, I'm going to answer the first one I see here, which is about the elevation. Okay, so I need to know, what is the source of elevation using epanet-js? Is it open topology? Yes, so I did see this one earlier. We use, oopsies, I can actually get this here. Mapbox Terrain DM. So this is our mapping provider and this terrain. So this is a blended terrain set that is a global data set. So it is a 10-meter DEM, but depending on where you are in the world, it can be either pretty accurate. So if you're in the US or Canada, I find it's extremely accurate. If you're in other places that especially are very remote, you're using like the 30-meter satellite elevations, which are okay, but not great. So yes, this is our data source. One thing I'll also say is on our roadmap, we have, this is our roadmap here, roadmap.epanet.js. We do have elevation. If you look, or user data elevation, something that many people ask for, being able to import your own DTM files and doing elevation. So this is something we know people want. If this is of interest to you, I would recommend you come in here and vote and ask for this feature. Okay, let's done answering. Okay, let me see. What's next? Okay, so this question is, hi, I'm looking forward to the workshop. Is wondering if it's going to support applying water demands patterns to projects similar to demand patterns. Yes, so that feature that we saw before, this demand patterns, is brand new. It actually hasn't been released yet. So this idea of being able to have the patterns and define them is coming. Probably in the next week, you'll be able to come in and do that. And the same with also being able to edit these patterns and add them in. So if you have like an external source of water that's coming through, we will have that ability to edit that. So just a little bit of patience, definitely by the end of the month, we'll have that in, that you'll be able to define time patterns. Okay, next one. How do you deal with assets that exist in GIS but are hydraulically inactive, closed valves, abandoned pipes? First one, I would say abandoned pipes. I mean, this is probably more personal preference, but I have never imported an abandoned pipe. I don't think it's necessary. Maybe someone's going to jump in and tell me why they think it's necessary. But for the most part, I just wouldn't bring them in. For the closed valves, it is possible to, during that import stage with valves, actually define the status being active, closed, or open. So you can bring those valves in and then also refer to a status to choose if they're open or closed. And the same with like check valves and things like that. So it is possible in that import to bring and set those values in. Actually, one of the big things that that's connected to bringing in closed valves and zones. I know we're just working a single zone. One of probably the most important things you do when you're first building a model, especially if you have lots of hydraulic zones, do the tracing and confirm that those zones are hydraulically tight, that the closed valves represent the polygons that you've got, because otherwise you're going to give yourself headaches where water is flowing to places that you don't expect. Okay, what ones have... so how do we save this work done on the custom allocation, use it later if we close the valve? So if you add those custom allocations and then you save, we save it as an IMP file, and then we keep that data in. I will say though, if you edit it later with a tool that is not epanet-js, you will lose that data, but it will come back in. So if you save that data with those customer points, they will stay in, and you can recall them and use them again, or remove those allocations. So you don't lose them if you close the browser. So definitely save the work. You'll be able to keep it. Yeah, so this is attached to the elevation data. I would recommend the data I've always used is the ASCII grid, but I know the LandXML files are also common. I would say if you have a file format that you want to see in the user elevation data, definitely comment in here that I would want to use this very specific file format, and then we'll support that too. It's actually, I'm not totally familiar with LandXML. Is it elevation or also detail files? I'm not sure. Actually, maybe I can check them after that and go. I've always seen LandXML as that, but maybe it's also like CAD files and imports. Potentially, we can support it. If you want a feature that we don't have, I recommend you come into the feedback, and you can actually go user request fields and put something in. Let me check that and make sure I don't look too silly answering. Yeah, so what's the advantage of epanet-js over Mike Plus? And I would say it's the same on InfoWorks, WaterGems, any of those other tools. I'd say that the biggest thing would be the main difference is, all those platforms, they all use the epanet engine at the end of the day, right? They use those same hydraulics. And even ones who have slight variations, physics is physics. And you'll still get the same results. So the two main benefits are we try to make it as simple and intuitive as possible. So we want it to be for those who are coming in available to use it. The other big point is it is open source, and we contribute back to epanet. So tools like Mike, InfoWorks, WaterGems have created derivatives of epanet and have not contributed back to the epanet project. And so being able to contribute back means that for the long term, we are all working together towards a better hydraulic modeling engine. And the third, which is probably also if you're price sensitive as well, a lot of the features in epanet.js are free for anyone to use. You can get in and do most of these tools itself. So there's no cost. And even when you do the paid versions, they are a fraction of the cost of things like Mike Plus. We're like $950 per year over many thousands. So the question is, can you perform simulations from an epanet? From an InfoWorks WS Pro model? So yes and no. The easiest ones are InfoWorks, WaterGems, and Mike Plus because they use epanet directly. So you can, for the most part, just export to epanet and get it going. InfoWorks uses its own slight derivative and their own modeling engine. So for most networks, you can export to epanet and have something that works, but there's a little bit more involved in getting it working because they have some of their own features. I would say if you've got an InfoWorks model and you can't get it running, come in contact us and let us know. I've never run into an InfoWorks model that I couldn't get running in epanet, because at the end of the day, you have pipes that have demands and you have controls that data that comes through. like it can be done. But the simple answer is it's not as easy to convert, but you can for some models just export it. So yes and no. Like I said, physics is physics. You can get things running. If you use InfoWorks, you have a little bit more work ahead of you. Okay, quite a few all in one. So there's can you draw and import shape files that describe a polygon? This is another one that's in here. I think polygons. Polygons. Yes, if you want polygons, vote this one, put a comment in. But yes, definitely polygons when we get into multi-zones are important. They are coming. There is also, I believe, live data is the next one. Calibration. I can't remember where it is. What should call this? There is or sensors maybe. I have to look. There is a one in here where we want to bring in that live data to do the comparison, right? So when you look at the field, being able to compare against live data, we will do that. It will be a static export and that come in. So yes, we will, that come too as well. Answering. So I'm not 100% certain what you mean by model calibration. We will have tools to help you do calibration. So people who have followed me in the past know I've built some tools to help you do calibration where you can quickly switch back and forth and change values and see them. The short version is yes, we will have some tools that will help do pressure calibration analysis, right? So once again, we've got this in here, being able to bring in that live data, being able to scale roughnesses or throttles, and being able to quickly see. So yes, we will have that soon as well. Once again, if you want this feature, you should vote here. One other thing I'll also add, we have been live for 6 months. We came out in the end of June. So everything you've seen is brand new. Like I said, we move fast. And we think this is a community effort. So hearing what people want is very important to know where we put our focus next. So we will have a calibration feature as well. And people have followed me and remember I've done similar tools in the past. I'm just going to tick onto this one. This is similar to the last one. Yes, we will have those calibration tools. I will say real-time monitoring calibration, this is more moving into the world of digital twins, right? Where you have the constant calibration, the constant checking of live data is a very hard problem and probably something that in the short, medium, or even long term, I'm not certain that we will do. We think there are tools out there that do this like digital twin, real-time monitoring calibration well, or at least are trying to do it. The existing vendors have their tools. There's a lot of startups are doing it. We want to be the tool that is really focused on planning, getting the model done and built so you can do operational scenarios, planning scenarios and some light operational work. We think some of these other digital twin tools, we can feed our models into there and they can continue to keep it going. Yes, this one for the recording. There'll be 2 ways that you can access this recording. One is you can come back to this link. Actually, once we close it off, you can go back and rewatch it. And like I said, I'll link to the file so you can get to them. The other is we have a YouTube channel as well, where we will post this video and we'll share it on LinkedIn as well. But Kevin, I can reach out to you and make sure I also send it to you directly too. Okay, is it possible to export the model to GIS software to make a layout and presentation? Yes, that's another one of these tools. Give me a second. I've been talking for an hour. Okay, if you're done with this, obviously you can take little screenshots and all those type of things, but we think we want to be a really great modeling tool with some good visualization. But if you want to do some great visualization in GIS, we have an option to be able to export the results. So once again, in the help utility apps, we have a data extraction tool here. In this data extraction tool, you can drag an IMP in and choose how you want to export it. So you can export the model to a shapefile, to a JSON, and you can also include the CSV results as well. The simulation results. So you can say, oh, and I want to attach the time at the peak hour, or I want to extract all results to CSV. And then you can download that and you'll get a dump of all the data and the actual GIS results too. So yeah, if you have an IMP, you can use that to extract that data as well. Yeah, interesting about Crowdcast and issues. If you're having a problem with that, just put it in the chat and see. Um, I don't know if it's like a localized issue, but yeah, do let us know if you're having problems with this platform in the future. We will also have the recording that should be of hopefully better quality. I'll have to look at the chat and see what people are saying about it. The transient analysis features down the road. Yeah, this is a really good one. So while epanet is an open source engine where we can run these type of simulations really easily and build on top of, transients don't have as many options there. Most of them are proprietary, except one engine that was recently sort of released by the University of Texas in Austin. Lena there, with some of her students, had developed an open source transient engine. Once we finish this, I would love to be able to see that evolve into a way that it could be used in a commercial tool or even like this type of thing. So not yet, but yeah, definitely something I think would also be very, very interesting. So how do we share these models? Yeah, really great question. So, like I said, in epanet-js, we're keeping everything local. These are your own files, so it's totally cloud independent and optional. So, the same way that you would share normal files, right? You can put them on your OneDrive. You can email people. You can keep them on a network drive. You can keep them local. Eventually, we will also include a cloud-based option where you can sync them to the cloud and share them with other people in your team, right? But for now, they're just a file on your computer, and you can share them in whichever way that you feel is most appropriate. And eventually, we'll have a cloud option for you too. Yeah, I'm interested in your thoughts on why you would like a desktop version. It would technically be possible. So you could wrap this all in a desktop tool, but at the end of the day, you're basically abstracting away the browser. Like I said, the application is delivered to you in the browser, but once you do it, you can actually turn off the internet. Obviously, I'm not going to do that because we're in this session, and then run the entire thing without any connection. We don't see any of your private data. Um, so there would be actually no advantage to doing a desktop version, but I'd be very curious on your reasons for wanting that. I mean, it would technically be possible, but yeah. Yeah, so yeah, under the license, there maybe I can actually go into the page how it works with the maybe if I go into an incognito mode. Oh, no, sorry. Let me see. I need to get a browser where I'm not logged in so you can see just a second. Yes. So if you use epanet.js, you can use it for professional purposes and without any restrictions. So for most people, you can get in and use a free version for anything you want. Commercial use, you can like sell consulting services, whatever you need to do. There is an option to upgrade. And when you upgrade, there's a couple options. You have a commercial use. So you have this free one, you have this professional version. And the professional version gives you professional support, custom layers, and then also coming very soon, scenario management. There is also a Teams version. However, there is a non-commercial version too. So the personal version gives you all those like paid features. So things like scenario management, which will come, but not professional support and not for only for non-commercial use, right? So if you want to use this in a commercial setting, yeah, you can use the free plan. That's not a problem. I'm totally happy with that. If you need to have professional support and a couple of extra features, yeah, you can also pay as well. These are also nice because you can contribute to the project. It helps go back to it as well, make this whole thing sustainable. Uh, we gonna. I know we're right on 10 o'clock. So if people have to go, I totally understand. I'm going to keep trying to answer more questions for at least another 5 minutes. But totally appreciate everyone coming through. Actually, maybe what I'll do is I'll just let me just have a quick look. Well, there's so many questions. First thing, I just want to end quickly. For those who want to stay, I'll answer a couple more questions. But I do also just want to say thank you because we're on time that people may have to leave. If you all do have to leave, make sure you check out epanet-js.com. Let me just throw up a little button at the bottom. you can click to try epanet-js now and actually get into the application. If you want to follow along, you can email at any point at Luke@iterating or connect with me on LinkedIn, and you will be able to ask as many questions as you want. You can follow on our development and see what's happening. So just quickly saying thank you for the people who have to leave right now. Otherwise, I'm going to just jump on to some more questions. But yes, thanks for those who have a tight schedule. Okay, because I don't want to leave people who need it. Let me see. From geopackage at the moment, no, it's only GeoJSON and shapefiles. Once again, if you think geopackage is helpful, drop it in the roadmap and we can get that in for you. Well, we can prioritize it and figure it out. You said load builder, like, I mean, that's sort of similar to the, I mean, I know that's a water gems thing. We have the custom imports. We think custom imports are going to be the big thing. If there is a particular difference that you want in way in loading demands, yeah, send us an email and I'll put in a feature request and we can look into it. So they don't need to be the shape files. Do they need to be in a specific format, or can you read this up? So yeah, I don't know if maybe you asked this before it came in, but yeah, you can just load in shape files. You just needed the projection file, and then you can select the attributes as they come through, right? So you pick where they get allocated to, which are the IDs and things like that. Hopefully that answers the question. Yeah, if there's a way to search for a particular area by just coordinates. It's actually a good point. We don't have a search feature at the moment in epanet-js. It's something that a lot of people have been asked for. But yeah, I think I can see some value in being able to like put in, you know, XY coordinates or assets and things. So yeah, I believe in the search we'll make sure to include that as well. So at the moment there's no way, but we'll get to that. So all model files are in IMP. Can they open somewhere else? Yes, definitely. We really want it to be portable. People are able to use these in any location they can. So you can build a network and then import into something like InfoWorks or water gems. I will say once you modify it or change it outside epanet-js, you will lose things like customer points and bits and pieces like that. Eventually, we will change it to our own custom format, so you won't have that issue. But we'll always support doing IMPs so people can choose what they want to do with it. Okay, last one. Chatbot. I don't have any plans to add a chatbot. There's probably some exciting stuff that we can do with AI in here. We don't use any AI features, but the chatbot will probably be the last thing I would have thought to do. But if you think of some good uses, yeah, definitely throw some comments in on ways that we can use AI and features like that. I think we've got all the questions, most of them coming through. I won't hold up people anymore from here. Last thing I'll say is keep an eye out. We have, if you maybe sneak the peer down here, this idea of scenario management is coming very, very soon in the app. This is going to be a really cool feature where you can load a scenario, make some changes, change the diameters, see the differences that happen, and then go back and forth between scenarios, run a scenario. Sorry, let me run the main scenario as well. And then actually start to see comparison differences in results. So right, see here, we can see the pressure. So very, very quick sneak peek of scenarios that are coming in. You'll probably see that in a few weeks, right? But yes, that's been another hotly requested feature. Okay, with that, if there's any other questions, what I'll say is, yeah, feel free to send me an email. Please connect with me on LinkedIn. I accept all requests from everybody. I take any questions. But I just want to say thank you so much for everybody who's attended and asked questions. And definitely all those who have posted about epanet-js. If you go on LinkedIn and share it, it makes a huge difference in getting it out there, a new free alternative open option for hydraulic modeling. With that, I'm going to close up the session. Thank you so much. And I'm going to go back and read all of the comments that came through as well. Thank you.